Okay.
Okay, we're solving, which means we want to get x by itself. Read to me what this says.
Natural log.
Okay, so what base does a natural log have?
3.
Let's try this again. What base does a natural log have?
Yep.
E.
Yeah.
Wait, what'd you say? E.
Third time. You know, this is where you would look at the note where it has it somewhere. What base does a natural log have? Thank you. That sounds more confident of the day before a test. Thanks. All right. So, if the base is e, how do I get rid of a log with a base e? I raise them to a exponent with a base of e. That cancels off the natural log. We drop down x equals e to the 6th power. Okay, well it says round your answers to the nearest hundredth. So then I'm going to type in e caret 6. If you round it to the nearest hundredth, what would this be? It's right above the division sign. Hit second, divide. 403.43. So x is about 403.43. Okay, questions on the first one. How to get rid of a natural log.
No.
Alright, next one. Read it to me.
Log 5x equals 3.
So does it say the base? Is this a natural log?
No.
So what's the invisible base? 10. The invisible base implied is a 10 if you do not see it. Not the same thing as a natural log. Okay, so how do I get rid of a log base 10? You use a exponent base of 10. So both sides are your exponents with a 10. Cancels off the log. We get 5x equals 10 squared. We're still not done because x is not by itself. Divide by 5. Now go ahead and put it in your calculator, although you should just know it. You get x equals 20. Doesn't say 10 divided by 5. It says 10 squared divided by 5.
Oh. Okay, I thought it was 2. I got you. I appreciate it. I got you.
Lucas has a question.
Do you have a question?
No.
No.
He said it out loud, but
He said, where did you
what
get
did
the 10?
you from?
And then John said, if there's not a log base, you assume it's just 10.
That's what I said.
Okay. So all those specifics, Lucas, remember I do have videos on all of that from when you were absent that I told you to be watching.
I didn't have any signal.
Alright, next one. This says e to the power of x minus 1 equals 20. So am I going to use exponentials to get rid of an exponential? We need to use a log. What's the same thing as a log base e? An ln, a natural log. So I'm going to take a natural log of the left side and a natural log of the right side. Drop it down. We have natural log of this and of 20. What cancels?
Oh, shoot.
The e and the natural log. So it drops down. X minus 1 equals natural log of 20. And we got one more step.
Plus 1 that's done.
Plus 1, plus 1. Can I add the 1 to 20 and make it 21?
No.
The 1 is not inside the log, so you are not allowed to add these. So keep it outside. Type it in your calculator. ln is right here below the log button. It's just mine's kind of faded out, but right here it says ln.
I think I'm wrong. but
Hit
now-
that, ln of 20. Close it, plus 1. So the 5 makes the 9 go up, which makes this 9 go up, which makes this become 4. Can y'all not do the sarcasm noises, especially if you're not fully correct, please?
I know exactly.
Okay, next one. Read it.
Log base 4 of x plus 5 equals 6.
Okay, so we know that this is a log with a base 4, so I need to use a what to get rid of that? Exponent base of 4. So raise both sides as the exponents, put a base of 4, cancels the log, and we get x plus 5 equals 4 to the 6th power. And you still have one more step. Okay, put it in your calculator. 4 to the 6th power minus 5 is 4,091. Questions on that one?
You really got that.
Huh?
You really got that.
Thanks. Okay, next one. This says 5 times 2/3 to the power of x plus 3 equals 25. So what is the base of the exponent? 2/3. The 5 is not directly below the exponent. The 5 is attached to the base. So I am not ready to use a logarithm until I get rid of that 5 that's attached to my exponent base. How do I get rid of the 5? Then we get 2/3 to the power of x plus 3 equals 5. Now I can get rid of the exponent base by using a log base. And I'm going to do log base 2/3 on both sides. Just because it's a weird number does not change the process. You're still getting rid of a exponent base.
Bro.
Okay, that crosses off the exponent base and log base, and it drops down. Drops down. Equals log base 2/3 of 5. You got one more step. Okay, put it in your calculator. We're going to say x is about.
I'm not confident. So.
We'll get confident.
I'm talking about this
Why?
because we got a negative number.
And
Yes, nothing.
okay, so we get negative 6 point.
Negative 6.97.
All right, questions on this one?
Wait.
Ask.
I lied.
What?
I thought you had turned it like decimal.
Turn what into a decimal? The 2/3?
Yeah.
But then it's an ugly decimal because it's going to be 0.333 repeating.
Just to do it.
Yeah, I tell you guys to leave things as fractions and do not round until the end of the problem. So that's why I always get x fully by itself, and then whatever decimal value I get is what I will round, because that's the most exact as you can be then. If you round in the middle of the problem, it alters your final solution. Okay, next one. So on this one, we have 12 times log base 2 of x minus 4 plus 2. Which one we get rid of first? Because we get rid of what's attached before what's not attached. We need to subtract the 2 first, guys. You get rid of what's furthest from the log. The 2 is not attached to it. So get rid of the 2 first. Subtract the 2. We get 12 log base 2 x minus 4 equals 12. Okay, now we can get rid of what's attached. The 12 is being multiplied, so I'm going to divide by 12. No, that is not 0.
1.
Okay, so we got rid of those values that were on the outsides of your log. Now I have to get rid of the log. What's the inverse of log base 2? Exponent base of 2. So raise both sides as an exponent with the base of 2. We get x minus 4 equals 2 to the first power.
So then just 2.
Pretty much just 2, yeah. And then what?
Then you only go minus 4, or plus 4.
Plus 4, plus 4. So 2 to the first power is 2. 2 plus 4 is
6.
Yo, Romeo.
Pencil.
Hey, bro.
Okay, we good there?
Indeed.
Okay, 3 more. Okay, this one's also an exponential. It says 5 to the power of 3x minus 4 equals 5 to the power of x plus 2. So since these bases are already the same, we're really just setting the exponents equal. Or if y'all want to get rid of them, what'd you say? We could do log base 5 of both sides to cancel that off.
Exactly.
Here.
Gone, gone.
What? Well, so if they just equal each other, like if they have both the same base.
Then you could pretty much just ignore them. Yeah, because you know that they're equivalent.
Yeah.
So the exponents have to be equivalent, which is exactly what we're doing now. 3x plus 4 has to equal x plus 2.
Okay.
Okay, so this is where some of you guys got stuck before because you guys want to move the 4 and the 2.
Yeah.
Okay, your object right now is to solve for x.
Okay.
That should be your focus first. Get the x's together. So start with the smallest number of x, which is 1x.
Minus x right there.
How do I get rid of this x?
Minus x.
Subtract x, and it zeroes out, but what I do to one side, I do to the other.
that can be
Now it
2x.
allows you to combine them. 3x's minus 1x is 2x.
Plus 4 equals 2.
Now solve for x like you would normally. Cover up the 2,
They go minus
subtract
4.
the 4, and you get
2x equals negative 2.
Did I write something? I wrote something
Why
wrong.
do you get plus 4?
Yeah, I know.
Yeah.
I just noticed that.
Where'd you get that?
White out.
Yeah, I was on it.
No, it's minus.
I know. That's why I'm getting a white out.
Oh.
So I was so confused.
I looked at it up there and I thought I had a plus. My bad.
I know it.
And this white out doesn't want to work.
You gotta push down on that thing.
Yeah, but I know that.
X equals 3, right?
My bad. Okay. So this was a minus 4, which means that we should have
Better do.
added 4. So 4 plus 2 is,
6.
and then last step is divide by 2, which gives us
3.
3.
I would have got that. You know, I would have got it if you would have. I would have got that. But, you know, I was messed up from the start.
Alright, next one. This one says 6 to the power of 3x plus 2 equals 7. There are no outside values. How do I get rid of the exponent base of 6?
Log base 6.
Log base 6 on both sides. Which cancels off the exponent base. So we drop down. 3x plus 2 equals log base 6 of 7. Do not type it in your calculator until you have x fully by itself.
Okay.
So the next thing. Cancel out what? What?
I can equal 1.
We're solving for x, Justin.
Minus 2.
Get x by itself. Subtract 2, subtract
You
2.
go put minus 2 on it.
Divide by
Okay. X equals log base 6, 7, minus 2.
Now divide by 3, so I divide all this by 3. Okay, be careful when you type this in your calculator. Is the log the only thing in the numerator?
Right.
No.
No, so how do I tell the calculator that all of that is in the numerator?
Parentheses.
Parentheses. Okay, so parentheses, math, log base 6 of 7 minus 2. Close it, because now it knows that all of this is the numerator. Divide it by 3, and you get,
I'm sorry.
Don't do it yet.
Yeah, don't do it. Hold on.
don't do what?
Don't. Oh, you already pressed enter.
Whoa.
Come on.
One thing.
One thing. One thing.
It's not too bad. Bam, got it. Oh, look at that.
So this is about
Are you proud of me?
3-0. Okay, another way that some of you guys probably did is you could have done log base 6 of 7 minus 2, pushed enter, and then take that answer and divide by 3. But that's 2 steps when you could have done it in 1. So negative 0.30. Alright, last one for solving, and then we're moving on. Okay, the logarithm is not by itself. We have to get rid of the 3 and the 2 first. Which one's furthest from the log?
The 3 minus
How to get rid of the positive 3?
minus that. Pump fee. Here you go.
10. Oh, yeah.
Yeah.
Damn, we must have got the answer wrong.
Hold on.
Yo.
Hold on, Missy, need backup, bro?
Miss, don't go, because you're going to come back in a bad mood.
I'm already in bad mood.
Oh, man. Not again.
Hey, bro, that's my water hole, bro. I gotta hold it down.
Fine, that's a 3.
Shut up.
Fine, that's a 3. What's it? 3.
Right.
Hey, bro, how much you want to start up?
Dude, I would've laughed. Lord.
Hey, I've done that before, though. That shit hurt. Hey, Romy, you did it the other day, right?
No, I felt up the stairs. I didn't fall down. You're going down and you just go.
You missed it. Oh, you missed it. I thought you meant you fell when you started rolling out. I was like, wait.
I can't do my business like that.
Must have been serious if she's out there that damn long.
I fell on the main
How you fall down?
That must be a really bad
So, is that how she made it, or like?
Oh, she did that makes you think, you know, like, the Mexican has like beer cans and then you won't let the beer go.
I'm just gonna take it. You know, like, I didn't know it was flat, so like, whenever I went down, I was like, oh, fuck.
So you didn't fall down the stairs, you fell on the flat part.
No, yes.
How do you do that?
I just told you, I'll show you whenever we go down there. You gotta catch me if I really fall though, right?
Catch me outside.
You don't catch me on this?
Oh, no.
Honestly, though, just
Like if you throw it, I throw it. And I'll do that. Yes.
it's not.
Hey, bro.
So it's gonna be like that one episode of Family
You
Guy.
already battled a bitch.
I don't know why.
No, like I done that before. My friend was going down, so I was like, I got you.
Did you really?
Yeah. Yeah.
Why? You're mad.
I don't know. It's like a little superpower.
He does.
It's man.
It's just like.
Oh, you wrong.
It does his name. I thought it was Ted.
Okay.
Someone died?
And his name, if you need backup.
Yeah, so like, we get a 300. Well, we don't know how to do it.
Something bad must have happened.
Just go up there. Oh, what do you do? Like, someone's right down the stairs, turn to you. Hey, look at it's fucking arcade over there. You know, you got over there? Just like, what you saw creeping up behind, like, all the shit. Dude.
I didn't see that.
What's the deal?
What happened?
Really?
Man,
I gotta mess
am I in
someone
the
up.
restroom or am I in a hole or something again?
Are they in my water
I
hole?
didn't see the restroom.
Nope.
You can go.
Alright.
Wow. Do it, right?
Okay, I'm gonna finish this one real quick. So we did 13 minus 3, which is 10. Then we would have divided by 2 to get rid of the 2. Then we get log of x minus 1 equals 5. Okay, from here it says log of x minus 1. There's no base there. What's the hidden base of a log? 10. Okay, so then in order to get rid of a log base 10, I raise both sides as an exponent, the base of 10, and we get x minus 1 equals 10 to the 5th power.
But isn't it plus 1?
Okay, and then from here we add the 1 and add the 1. So 10 to the 5th power plus 1 gives us 100,001.
And one.
What? Hey,
Alright, next piece. I start reading and you finish the sentence. Otherwise, we keep reading the same sentence. That's for natural log, Lucas.
Do like some sort of word.
And then we're not gonna be able to understand.
Okay, Kathy plans to purchase a car. Okay, that word says depreciates.
Oh, okay.
Kathy plans to purchase a car. It's a little bit better, even though we still got a person not reading. Kathy plans to purchase a car. That okay, what does depreciate mean? Go down in value. Okay, the initial cost. The initial cost of the car is? Okay. So when you're formulating an equation, yes, I know I was typing really fast and there's some errors in my typing. Excuse me. Okay, so if you are formulating an equation, that means you do not know what x is, you do not know what y is. You are modeling this situation for any input and output. So like any other equation, what does y start with? We need to know the initial. 21,000. Okay, but 21,000 is depreciating at a rate of 14%. Does that mean multiply it by 0.14? No. It means that you're losing 14% from the original full percentage. What does it mean to be the original full percentage? 100%, which is the 21,000, minus the rate of 14%, since you are losing, which gives you 86%. So what am I really multiplying by? 0.86, which is less than a whole, like it should be. But do I multiply by 0.86 one time?
No.
It's a repetitive thing because it says it happens per year. So how do we represent repetitive multiplication? X as an exponent. A lot of you guys will leave off the x there and just give me y equals that. That makes no sense because then you're telling me y equals that number forever. You don't know what x is, so put it up there until I give you more information. This models the scenario for any input or output. Alright, next part. It says, how much will the car be worth in
4 years.
What do I do with 4 then?
You change it.
Put it in the x. So we go 21,000 times 0.86 to the power of, here's your caret right there, caret 4, and we get about 11,047 and 17 cents. Now before you move on, when you guys took a quiz on this, I had some of them that made no sense at all. Does this amount make sense for the problem? Does this amount of money make sense for this problem?
Yes.
We'll read the problem and see if it makes sense.
Yes.
Why does it?
Because it's
decrease.
over 4 years.
It's decreasing. It's depreciating. So is that amount less than the initial?
Yes.
Yes. If it was something crazy big, then obviously you did something wrong, and that's for you to fix. Okay, the last one. When will the car be worth $8,000? Do not put it in your table because the table will round it. We want to know as exact as possible. So where would I put the 8,000? In the y. So I get 8,000 equals 21,000 times 0.86 to the power of x. Solve for x, just like how we did in all the equation above. So if I want to solve for x, get rid of what's attached to the 0.86. How would I do that? And I told you guys not to give me the decimal until the very end. So leave this as a,
Oh, cool. Like, how many fractions are?
leave it as a fraction. And how do I get rid of that 0.86 as a base? Log base 0.86 on both sides. So now is where we would type it in the calculator. Log base 0.86 of 8,000 over 21,000 gives you your x. So it's about how many years? point.
And it's 6.4.
6.4.
Yeah, 6.4.
Yep. The 8 rounds the 9 up, which rounds the 3 up, so it'd be 0.40. So we have about 6.4 years. Is it possible to get decimal of years? Yes, there's months and days. You can break it down. You can have decimals of years. Okay, question on the formulating.
No.
Okay, what if it said it appreciated or it increased? What would you have done differently? You would have added the 14% instead of subtracting. That's the only difference. So this minus meant that we decayed.
Would have been 1.
It would have been 1.14. So if it's increasing, you should be bigger than a whole. If it's decreasing, you'll be less than a whole. Yes. Yes. Okay, flip it. Now we just got a graph and then we'll be done. So do not forget with the graphs, if we have exponentials, your parent function for an exponential is y equals whatever the base is to the power of x. It doesn't matter what the base is because the base just represents the original parent. For logarithms, the parent would be just log base b of x. So whatever else you see in the equation that's not the parent would be called a transformation. And we went over the a, h, and k values time after time. So for the first one, this is a exponential or a logarithm? Exponential or logarithm? Run
Logarithm.
Because you see the word log, right?
Yeah.
It's an exponential because the x is in the exponent. So if this is an exponential, what is the base of the parent function? 2. So 2 to the x is the parent. Your a value then is 3. So what happens to a graph when you multiply its outputs by 3? They stretch. So we stretch by 3. Okay, where's your h value? The h that changes your horizontal movement. The +1, where is it next to? The x. But we always inverse what's changing x since it's not by itself. So you translated left 1. And the last transformation is the -4, which is on the outside. So it shifts your outputs down 4.
Quick question.
What? What?
I was going to say, what does it mean for
I told you. I said that it was the parent,
Yeah, that's what I see.
the original. So b to the x is the parent function. Everything else is what transformed that function.
Just stay right.
Okay, now let's do the log for transformations before we graph them. So on this one, the log base 2 of x is the parent function. Everything else represents a transformation. So what is the third going to do if I multiply the outputs by a third?
Is the orange compress?
Compress by 1/3. And then my h value is the -3 since it's inside with
So
x.
it's going to translate right.
We inverse that. It translates where?
Right. It's right.
And the last one is the +2, which is on the outside. It shifts your outputs
Shift
up 1. I was about to say 1. Shift up 2. Thank you.
I said
Okay. Now, what if I had a negative in front of both of these?
reflect.
Then it would have reflected. Would it have changed the stretching and compressing?
No.
No. This still would have compressed if there was a negative. And this still would have stretched if it was a negative. The only difference is we would have had an extra transformation and said that it reflected. Okay? How does that not make sense?
I said that makes more sense.
Oh.
Because
I was like, I just explained that earlier.
Yeah.
You can stretch and be in the negative direction. So you can be taller and upside down at the same time. All right. Let's put the first one in our calculator. Go to y equals 3. Whoa.
Whoa.
Times 2 to the power of x plus 1. Hit the right arrow. -4. Hit graph to get your sneak preview. So that's what it should look like. Obviously, we are going to have a horizontal asymptote since you see it kind of evening out right here like it's approaching something. Like I said, go to the table and see what it is that you are approaching. Well, as the x's get bigger, do they look like they're approaching something? Nope. But as they get smaller, they're getting closer to -4, where eventually it even says -4. But if you hit the right arrow, it's not at -4. They're just getting really close to it. So what is -4 as my asymptote? Is it y equals or x equals? It's y equals. And how would I graph this asymptote? I go to -4 on the y-axis, 1, 2, 3, 4, and I draw a line going through it. The only way to go through just -4 would be this way. That's y equals -4. Good there. Okay, now we can graph the rest of the values. We have between -10 and 10 to plot as many points as we need, just to figure out what the graph looks like.
0 and 2.
So I go from -10, it's super close to -4. So basically we're starting at hugging that -4, like we're practically on it. Okay, then I scroll away a little bit more. Let's see, which one do I want to use? Maybe that one. -3, -3.25. Go to -3 and down 3.25. Okay, then we got -2, -2.5. So we see it starting to increase some. -1, -1. 0, 2, what is that coordinate called? That coordinate's called something. That's your y-intercept, since that's where it's crossing the y-axis. Keep going, 1, 8. And then the next one goes off the grid. We can't graph anymore. But we do have a good image of what's happening. As the x's are increasing, my y's are going to infinity. And as the x's are decreasing, my y's are approaching the -4. So there's your exponential. Now what's funny though is that I looked at some of your quizzes and I saw your graphs crossing the asymptote, which means that you probably put the wrong asymptote. I also had some people drawing the asymptotes going this way, and again, if you're crossing it, then you probably messed up. The asymptote is what you approach. It should hug it. Alright, let's do domain and range. So follow the blue line. How far to the left will the blue line go? Negative infinity, because the x-axis keeps going. How far to the right? So the domain is really all real numbers. Yes, you may write that if you know that it is all real numbers. Okay, how far down will it go? -4. How far up will it go? Infinity. So from -4 to infinity. How come I did not use a bracket?
Because it's not.
You can't equal it. It's not exactly -4. You approached it. Okay, x-intercept. We're going to have to estimate it since we don't have the exact value in our calculator. It's in between -1 and 0, but a little bit closer to -1.
75.
That'll work, but it's not 0.75. It's on the left side.
Oh shit.
Okay, where's the y-intercept at?
Down on 2.
It's a coordinate.
Yeah.
0, 2. Those of you that are still giving me numbers and equations are wrong. It's a coordinate. You give me a coordinate. X comma y. Alright. We got 5 minutes to graph this next one. We can do it. Y equals. Clear. Put the 1/3 in parentheses. Go to math. Log base 2 of x minus 3 on the outside plus 2. Graph it, like I said before, even though it looks like it is stopping there, what is happening? It keeps decreasing, but it's hugging that vertical asymptote. We need to figure out where that's at. So go to the table. It says errors on all of these. Where was the very first original error? It was at 3. So that was where the wall existed. So it keeps decreasing, but it will never reach 3 because at that x value it is undefined. So what would I write as my asymptote? And how would I graph that? You go to the x-axis at 3, and then you draw a line through it. There's your vertical asymptote. Now we can start graphing the rest of it. Yes, Justin.
No, I'm just searching.
Okay, so we got 4, 2. 6, 2.5-ish. So it's slowly increasing, but it is increasing. 9, 2.9-ish. So we see that as it's going to the right, it's slowly increasing, but as it goes to the left, it is decreasing and approaching that asymptote. So do I leave it like this? And that's my graph. No, like I said, this keeps decreasing because there's numbers between the 3 and the 4, all those decimal values. So it's going to keep going down, and it's going to hug that asymptote. It will not cross it. Questions on graphing the logarithm? This is a vertical because it's vertical, up and down.
I just wanted this a horizontal.
That's this one. There's not both. It's not rationals. Okay, domain. How far to the left will it go? 3. How far to the right will it go? Infinity. So our domain is from 3 to infinity.
And then ranges all the numbers.
How far down will it go?
Infinity.
Negative infinity. How far up will it go?
Infinity.
Positive infinity. So yes, it's all real numbers.
Here,
Okay, x-intercept. We have to estimate it again. It's in between 3 and 4, but a little bit closer to 3 probably. Give me a decimal value.
We said that X.
3.5.
X-intercept. 3.5?
3.25. 3.3.
Yeah.
3.3 would work. That works. 3.3 comma 0. Do we have a y-intercept?
No.
No, because it won't even cross 3. So how is it going to cross the y-axis? It won't. Do I leave it blank?
No.
Do I put 0?
It ain't.
No, you put NA or you put none. You tell me that there's none. Okay, please study this. I know I took a long break. I'm sorry. But this is a good foundation for you guys to review for tomorrow.